We welcome every one of you to the discussion of logical reasoning or mental ability area of CUET exam. By the way, my name is Dr. GM. You may be wondering what is a full form of GM, that is Guy Verghese Matthews. Our focus is on logical reasoning, or pretty much there is another name for it, it's mental ability. Probably you must be aware of the name logical reasoning. We will use that name, logical reasoning. So what is logical reasoning? What is logic? Logic is nothing but common sense. If you have common sense, then you are good for any kind of exam. It is not just the CUET exam, any kind of competitive exam you attempt after your degree or your PG or for the placement, doesn't matter. Any kind of exam, one of the paper is what? Logical reasoning. They need to really check out whether you have the common sense or not. That is the purpose of this paper. So logic, that's pretty much common sense. And by the way, how do they check the common sense of the candidates? There are different ways of checking the common sense of the candidates in a competitive exam. They may ask you the questions from multiple areas that is connected to logic and reasoning. Well, these areas are number series, letter series, blood relations, coding, decoding, calendars. Sometimes it could be syllogism, and sometimes the questions are, it is not really verbal reasoning, it could be non-verbal reasoning. There could be some pictures, all those kind of things as well. Anyway, we'll take a look at some of these questions. You get a clear idea what exactly it is. Well, one of the questions right here, this is what you have. Which of the following numbers will replace the question mark in the given series? So it's a series-based question. So it's pretty much, we call it number series question. So what is the pattern here? Every number series, there is some kind of a pattern. If you are able to find out what exactly the pattern, then it is easy for us to solve that question. So we'll take a look at what is the pattern here. Before that, I'll introduce some kind of interesting patterns for you, the common patterns that appear in competitive exams. Well, one of the pattern is summation pattern. That means, let's say some of the numbers are like 18, 23, 28. The next number is 33, etc. So this is a number series. So what kind of a pattern here? If you see the difference, 18 plus 5 is what? 23. And 23 plus 5 is what? 28. And 28 plus 5 is what? 33. See the pattern? And if the differences are like 5, 5, and 5, the next difference is going to be 5. So here is a pattern. The difference between the numbers, it's 5. Next one, 33 plus 5, 38. That is one of the simple example for number series question. This is one of the pattern you have. You may have different varieties of patterns. For example, like 18, 21, 25, 30, and we have 36. What's the next number? Here, if you look at the pattern, you see that difference, 18 plus 3 is 21. Let me take another color for that. So this is 3, difference is 3. And 21 plus 4 is 25. 25 plus 5 is 30. 30 plus 6 is 36. So 3, 4, 5, 6. Next one is what? 7. So 3, 4, 5, 6. Next difference is 7. So 36 plus 7, how much you get? 43. So the answer for this question is 43. That's another summation pattern. Well, rather than the summation pattern, you may have many other patterns, but let's go with the summation pattern for the different possibilities of summation pattern that may appear in exams. Like this is a constant number is a difference here, 5, 5, 5. Here the differences are 3, 4, 5, 6. Those differences are what? They are the natural numbers or counting numbers starting from 3, 3, 4, 5, 6, etc. What are the other possible patterns that appear here, these type of questions? Let's take a look at. We'll take another example. Let's say 9, 10, 14, 23, 39. What's the next number? So what is the difference there? We'll take a look at that. 9 and 10. What's the difference? 1. 9 plus 1 is 10. Well, 10 plus 4 is 14. 14 plus 9 is 23. 14 plus 9, 23. And 23 plus how much is 39? 23 plus 10 is 33. 33 plus 6, so 16. So the differences are what? 1, 4, 9, 16. I'm pretty sure you got it by this time. So this is 1 square, this is 2 square, this is 3 square, 9, and 4 square, 16. So the differences are 1 square, 2 square, 3 square, 4 square. Next difference, 5 square, that's 25. So 39 plus 25 would be the next number what you're looking for here. And that is square pattern. Sometimes this, this differences of numbers could be cubes. That means that the first difference could be 3 cube, next one 4 cube, 5 cube, 6 cube, 7 cube, etc. Sometimes these differences are like prime numbers. The first difference is 2, second difference is 3, next difference is 5, then we have 7, then we have 11, 13, etc. And you see these wide varieties of pattern in this kind of question. So this is pretty much one type of series. That means what? Summation. The first number plus something is the second number. Other than summation, what else we may have? We'll take a look at another set of questions. Another set of examples. Let's say 24, 35, and 48, 63, and the next number. What's the next number in the series? Here, if you look at 24 and 35, what is the difference between 24 and 35? Well, that's 11. 35 and 48, that difference is 13. So here the difference is 11, this is 13. What's the next difference? 48 and 63, that's 15 is the difference. So 11, 13, 15, what are those numbers? These are odd numbers, consecutive odd numbers, 11, 13, 15. So naturally, next difference is going to be 17. So 63 plus 17, it's 80. That's one way of finding the answer for this question. So that method is perfectly all right for this question because there's a 2-digit numbers here. Sometimes you may get 3-digit numbers question. If it is question bit challenging, you may get 3-digit numbers. That case, finding difference would be a little more challenging. We'll take an example. Let's say 362, 402, 401, well, 442, 485, what's the next number? In this case, it's possible to find the difference, but that finding difference would be a little more time consuming than this question. The reason for that, this is just 2-digit numbers here. These are 3-digit numbers. And when the numbers are large, this calculation or just finding that difference would be a little more time consuming, and that would be challenging as well. So what is a different method you can adopt for these type of questions, these two questions? First of all, we look at this question 24. So what is some kind of a different pattern you see there? 24, well, when I see that 24 and 35, what come to my mind? There is a number which is near to 24, it is 25. 25 is what? 5 square. And this is 35. There is a number, 36, which is near to 35. That's 6 square. So 5 square minus 1. 5 square minus 1, it's 24. 6 square is 36. 36 minus 1, that's 35. And next one is 7 square minus 1. 7 square is 49. 49 minus 1. And next one is 8 square is 64. 64 minus 1. So now you see the pattern. 5 square minus 1. 6 square minus 1. 7 square minus 1. 8 square minus 1. Next one is what? 9 square minus 1. See that? So 9 square minus 1 is what? 9 square is 81. Minus 1 is 80. So here we get the answer 80. Or if you look at the other way, 63 plus 17, that's 80. We get the same answer. However, this method is less time consuming. That is one of the most important thing you have to have in your mind when you approach competitive exams. Save as much as time you can. Because you know what, some of the questions would be much more challenging than what you expect. So those questions you need to spend the extra time. So that extra time can be saved, or that extra time, where you get that extra time, you don't get the extra time for the total exam. The exam time is fixed. So that extra time for difficult questions, you may get it from, or you manage from what? Easy questions. So you save time on easy questions, invest that time on difficult questions. So you must be in a position to do as many questions as possible. Alright, so this one, 362, 401. I like the number 401 because this is 20 square. I know that 20 square. Everybody knows that 20 square is what? 400. So this is 20 square plus 1. And, well, if it is 20 square plus 1, this number is less than that. It could be what? 19 square or 18 square, whatever it is. So let's check it out. What is it? 19 square? 361. So this is 19 square plus 1. And how about 442? Well, next one is what? 21 square, right? 21 square is 441 plus 1. Then 485. 485 is 22 square. 22 square is 484 plus 1 is 485. So it is what? 19 square plus 1, 20 square plus 1, 21 square plus 1, 22 square plus 1. Next one must be 23 square plus 1. So what is 23 square? 529 plus 1, 530. At the same time, I'm pretty sure some of you have tried that finding differences method as well. So if you try that method, you get the answer definitely. 362 and 401. How much is the difference? 362 plus 40 is 402. So it's 39 difference. And well, this 401 and 442, that difference is what? 41. And 442, so 42 and this is 485, so 85, 42 and 85, that difference is what? 43. So you see that? Differences are 39, 41, 43, these are consecutive odd numbers. So next difference is going to be 45. So 485 plus 45, 485 plus 15, that's 500. 500 plus 30, 530. So we get the same answer right here, 530. Use either one of the method. So the square method is time consuming. The other method is nothing wrong with that. It is bit time consuming when you compare with the square method. So if you know the squares, that would be much more easy. So this is another pattern we have. What is it? Square method. Or the squares of numbers. So this is what? 5 square minus 1. This is pretty much, generally we call it square minus 1 pattern. This is square plus 1 pattern. Similar to this, we have square minus 2 pattern, square minus 3 pattern, square minus 4, or square plus 2, square plus 3, square plus 4, all those kind of patterns. Rather than squares, we may have cubes as well. Sometimes you may have what? Cubes. Cubes of numbers minus 1. Like 2 cube minus 1, 3 cube minus 1, 4 cube minus 1, 5 cube minus 1, 6 cube minus 1. Sometimes it's cube plus something, cube plus 1, cube plus 2, cube plus 3, cube plus 4, all those kind of possibilities. Alright, so that is another type of questions from what? Number series, another pattern from number series. We'll take a couple of more examples before we get into these questions. Look at this one, 2, 2, 4, 12, 48. Or what's the next number? Any idea? If you take difference, 2 plus 2 is 0, 2 plus 0 is 2, and 2 plus 2 is 4, 4 plus 8 is 12, 12 plus, how much is 48? 36, right? So the differences are 0, 2, 8, and 36. However, that doesn't give any specific pattern at all, right? Anything else? I'm pretty sure at least some of you have noticed it. There is a pattern. It's a clear pattern. What is it? Well, 4 into 3 is 12, 2 into 2 is 4, and 2 into 1 is 2. So 2 into 1, 2, 2 into 2, 4, 4 into 3, 12. 12 into 4 is 48. 48 into 5. What is that? 48 into 5. Well, 50 into 5 is what? 250. 48 into 5? 50 into 5 minus 2, correct? 50 minus 2 is 48. So minus 2 into 5. Minus 2 into 5 is 10. So 50 into 5, 250 minus 10. So what is it? 240. Did you get that mental calculation? This is what? 48, we take it as what? 50 minus 2. For mental calculation purpose, we don't write it, but you assume that this is what? 48 is 50 minus 2. And we need to multiply. Instead of 48, we take 50 minus 2, and it must be multiplied by what? 5. So 50 into 5, 250. And what is it? 2 into 5, 10. So 250 minus 10. So that is what? 240. That is how we use that mental calculation. Alright, so this is pretty much one of the examples for what? Multiplication. Multiplication type of question. I'll show you another example. Here it is what? 3, 4, 10, 33, 135, maybe 136. What's the next number in the series? Any idea? Check it out. If you take difference, is what you see, 1. Difference is 1. Here the difference is 6. Here the difference is 23. And here the difference is 103. So is there a pattern? If there is a pattern, perfectly all right. If not, we have to look at something else. What is it? Any idea? And another interesting thing, what you see here, 10 and 33, you may see that 10 into 3 is 30, plus 3 is 33. Same way, 4. 4 into 2 is what? 8. 8 plus 2, 10. So into 2 plus 2, into 3 plus 3. This one is what? 3 into 1 plus 1. Into 1 plus 1, into 2 plus 2, into 3 plus 3. Next one must be into 4 plus 4. Well, 33 into 4. You take it as 30 plus 3 into 4. So what is it? 30 plus 3. There is no need to write in normal case. This is just for the explanation. So, well, 30 plus 3 into 4. So 30 into 4. That's 120. Then 3 into 4. 3 into 4 is 12. 120 plus 12 is 132. 120 plus 12, 132. Plus 132 plus 4, 136. Perfectly all right. Now we have answer. 136 136 into 5 plus 5. Again, how do you multiply 136 into 5? The best method is 100 plus 36. 36 into 5, if it is convenient for you, you can use that method. Or you can take it this way. And again, there is no need to write it. This is just for the explanation purpose. So 100 into 5, 500. 30 into 5, 150. So 500 plus 150, 650. Then 5 into 6, 30. 650 plus 30, 680. Alright. So 500 into 5, 500. Well, 30 into 5, 150. 6 into 5, 30. 150 plus 30, 180. 180 plus 500, 680. 680. So plus 5. 680 plus 5. 685 is the answer. So this is another pattern you have. What is the pattern here? Multiplication and addition. And sometimes it could be multiplication and subtraction as well. Sometimes you may have what? Into 2 minus 2, into 3 minus 3, into 4 minus 4, into 5 minus 5, into 6 minus 6. All those kind of possibilities. Sometimes this multiplication only with the prime numbers. You may start from like 3 or 5, whichever the prime number which is given in the question. The first number is multiplied by, so first number, let's say x. X is multiplied by into 5 plus 5. Next one, next number, that must be multiplied by 7 plus 7. And the next number multiplied by the next prime number into 11 plus 11. And the next number multiplied by into 13 plus 13. So it goes like that. So this is multiplication with the prime numbers. Sometimes that could be subtraction as well. What means into 5 minus 5, into 7 minus 7, all those possibilities. Sometimes, you know what, there could be an interesting patterns like this. Into 2 minus 1. Second number it's multiplied by 3 into 3 minus 2. And well, this is into 4 minus 3, next one. And next number is multiplied by 5 into 5 minus 4. So these questions are a bit more challenging questions. Usually these questions, I believe these kind of questions do not appear in CUET exam. But if you go for like a SSC exam, Staff Selection Commission exam, or maybe a bank test, or maybe like MBA entrance after your degree, all those kind of things, CAT, NMAT, well, sometimes some of you go for GMAT type of exams as well, doesn't matter. So those kind of competitive exams, more challenging questions may appear. For CUET, you know what, the questions would be reasonable, not that challenging, but however, you know what, you never know, some of the questions would be a little bit challenging, but not all of the questions. Alright, so let's take a look at this question here. And of course, there would be a few more patterns that are in this number series. We are not going to cover all those patterns. We just cover the patterns which we require for CUET exam. And when we discuss these questions, definitely we go for, you know what, other patterns as well. Okay, so let's try this. 15, 27, 12, etc. So what is the pattern? Is there a pattern here? What I see here, 15, 27, 12, and we have a question mark here, that's a blank space. Then we have 9 and 33. So if you take differences, 15 plus 12 is 27. Okay, so here it's 15, here it is 12. So the middle number is 27. 15 plus 12 is 27. That's one way of looking at it. And if you apply the same pattern, 27, and there is a number here, if you add those two numbers, you need to get 12. 27, you know why we follow that pattern? This is what? First number and the third number. If you add those two numbers, we get 27, the number in the middle. Now we take these three numbers, or maybe these three numbers. These three numbers. Again, when you take the sum of 27 and this number here, whichever the number, we need to get 12. If it is 27 and a number here, if you add those numbers in order to get 12, the number over here must be a negative number. We don't have any negative number in the answer choices. So that means that pattern doesn't work. So what else we do? Any other pattern? Next possibility, 15 plus something is 27, right? So 15 plus 12 is 27, 27 and 12, what's the difference? It's minus 15, okay, so plus 12 minus 15. And 9 and 33, what's the difference there? 9 and 33, 24 is the difference, 9 plus 24. So this is 12, this is 15, this is 24. What would be the differences between these? 12 and what? Some kind of a number here. It's either 29, 18, 26 or 30. So some kind of a number appear here. And 12 and that number, what's the difference? And that number and 9, what's the difference? Do we get a pattern altogether? That's what we are looking for. I don't see any kind of pattern here if you go with that kind of differences. So that method or that kind of like, taking differences, that approach doesn't work for this question. So what else we do? Another interesting factor what I see here, 15, 12, 9, these are alternate numbers. So 15 minus 3 is what? 12. 12 minus 3 is 9. And if you take another set of alternate numbers, what is 27, the number here, and 33 here. So 27 and this number here, and this is 33. So this is minus 3, minus 3, minus 3 pattern. Then 27 minus 3 is 24. We don't have such an answer choice here, right? So that's not possible. Then how about 27 plus 3? 27 plus 3, that's 30. 30 plus 3, that's 33. So the pattern, you see that? For alternative numbers, 15, 12 and 9, the pattern is minus 3, minus 3. For the other set of alternate numbers, 27, 30 and 33, we see the pattern plus 3, plus 3. So ultimately, what is the answer? 30 is the answer, right here, 30. See the question? Well, it is not that easy, and at the same time, it's not that difficult. It's a kind of a medium type question. And I'm pretty sure many of you got that answer before I explain it. Okay, let's take a look at the next question right here. This is another number series question. So let's try this question. 13, 14, 23, 48, etc. Okay, let's try this. 13, 14, 23, 48, 97, 178. So what's the next number? Well, 13 and 14, the difference is 1. 14 and 23, well, 14, 23, what's the difference? Difference is 9. So 1, next difference is 9. And 23 and 48, if you look at the difference, what do you see? 25 is the difference. So 1, 9, 25. Does it make any sense? Or how about like multiplication? 13 into 1 plus 1 is 14. 13 into 1, 13 plus 1 is 14. 14 into 2, it's 28. 28 plus 2 is 30, but it's 23 is given. So that doesn't work. So 13 into 1 plus 1, 14 into 2 plus 2 doesn't work. How about 14 into 2 minus 2? 14 into 2 is 28. 28 minus 2 is 26. Again, it's not 26, 23. So that pattern doesn't work. What else? Anything else? I'm pretty sure you have that pattern here. 1, the difference is what? 1. And this is 9. And this is 25. Is there any peculiarity for these numbers? Well, 1 is 1 and 9 is what? 3 square. So this one you can take it as 1 square. This is 3 square. This is 5 square. If you take it that way, what's the next difference? 48 and 97. 48 plus how much? This is 135. Next one, if it is 7, 7 square is the difference, then this must be 49. So 48 plus 49, how much is that? 48 plus 49, that is 97. Perfectly all right. So the differences are 1 square, 3 square, 5 square, 7 square. Next one must be 9 square. 9 square is what? 81. So 97 plus 81, how much is that? 97 plus 3 is 100. So from 81 we take that 3. Balance is what? 78. So 178. Perfectly all right. What is the next? 11 square. So 11 square is 121. So 178 plus 121, how much is that? So 178, the last digit is 8, plus 1, 9. So we are looking for an answer which is ending with 9. So 3 answer choices are ending with 9. So we need to have a perfect answer for that. So what is it? 178. 178 plus 121. 178 plus 22 is 200. Well, we are taking 22 from here. Balance is how much? 99, right? So 200 plus 99. So what is the answer? 299 is the answer. So question number 2, what is the answer choice? D, 299. What's the pattern? This is 1 square, 3 square, 5 square, 7 square, 9 square, and 11 square. So this is one of the pattern we have discussed earlier. The differences are squares of numbers. But in this case, the squares of what kind of numbers? Squares of odd numbers, not consecutive numbers, odd numbers. Well, consecutive odd numbers, but not consecutive natural numbers. Alright, so let's try the next question. This one. Well, I'm not sure whether you can see this picture. Well, let me draw that picture a little bit larger. So this one, actually this is an arrow. This is dotted lines here. This is an arrow. It's something like this. That means this page is folded towards the side. This is a square piece of paper and this is folded towards the side. So let's say here is the paper what I have. This is a square paper, and what exactly they have done here? The square paper is folded towards this side. This side. Okay, so this is folded towards this side. Something like this. So actually it exactly looks like this. So let me keep it this way. Alright, so this is folded like this. So this is square paper, this is folded. And after folding this, you know what? It's folded again. So that means it is folded like this. And certain markings on this paper. So can you see that markings? The markings are like the first one, it's an arrow, something like this. This is the first one, and second one is a circle, and this one is a triangle. After folding this paper, you know what? This part, this arrow is cut on this part, and a circle is cut on the center, and a triangle is cut on the bottom. And after cutting these shapes, 3 shapes on this paper, so cutting means, well, cutting means all the pieces cut together. That means we are folded it 4 times, so it is folded like 1. So now it's 2 layers of paper. Now it's folded again. So 4 layers of paper. So when we cut, all the 4 layers are cut off. That means cut with this shapes here. And after cutting, this paper is opened completely. Opened completely, exactly like this. And then what kind of an image you see on that paper? That's a question. So take a look at this. This is arrow. This arrow is right here, this way. And this paper is opened. That what happened to that arrow? Well, on this paper, we'll have that arrow right here. At the same time, when this paper is opened, so you may take a piece of paper and you can just, fold it and cut it using your pen and open it, you see the exact picture. Or you can just visualize it. If you have the capacity to visualize it, that would be much better. If you don't have that capacity to visualize, take a piece of paper and do it by yourself. Alright, so anyway, so you'll have this, when you open, you have the arrow facing this direction, and we'll have another arrow facing this direction. So ultimately, when you look at this answer choice, both arrows are facing that direction. So that cannot be the answer. And here this arrow, these two arrows are facing each other. Okay, these two arrows are facing each other. That's a possibility. And how about a triangle? When we have this triangle, when we cut the triangle here, when we open it, what happens? This triangle would be like this. It would be like this. When you open it, and there will be original triangle would be like this as well. So ultimately, when you look at this, you can see this. So arrows and triangles are right here. And well, in this case, both arrows are facing, these first two arrows are facing the same direction, so that cannot be the answer. Here, these arrows are facing each other, but the triangles, these two triangles are facing the same direction. No, it should be just opposite direction like this. So this cannot be the answer. So the best answer is what? Beta. Second answer choice. So this is what exactly happens in this question. So this is called paper folding and cutting type of question. This is a non-verbal reasoning type question, non-verbal reasoning. So paper folding and cutting. A paper is like, it's given as what? Folder. Actually, this is what? A paper is folded. This is a previous question. That's a minor spelling mistake in that question. So a paper is folded and cut as shown below. How will it appear when unfolded after cutting? So that is what we have done here. Right, next one. Here in this question, study the given pattern carefully. So we'll take a look at what is the pattern here. Study the given pattern carefully and select the number that can replace the question mark. So here is a question mark. We need to find out the number which can be here. Instructions. So operations should be performed on the whole numbers without breaking down the numbers into its constituent digits. For example, if a number 13 is given, in this case no 13 is given, but they are giving you an example how to do the operation. If 13 is given, operation on 13 such as adding or deleting or multiply 13 can be performed. However, breaking down 13 into the digits 1 and 3 and then performing mathematical operations on 1 and 3 is not allowed. That is not allowed for this question, but some other questions you can do that if you want to do it. But this question, those kind of operations is not allowed. If 13 is given, you have to take 13 as the whole number. Don't take it as 1 and 3. And similar thing here, we have 43 is given. Don't do any kind of operations like don't take 4 separate or 3 separate. That's what they mention in this question. So this direction is applicable only for this question. If you get some other question and if you have a number 13 is given, if you want to take it as 13 as 1 square and 3 square, you can do it. However, for this question, that method of approach is not allowed. That is what exactly the direction is given. Now look at what? 3 and 4. So 3 and 4, what is given here? 43. So second number, the number in the third column is 4 and number in the first column is 3. So these two numbers, if you take it, 4 first and 3 second, you get 43. So if that is the case, if you apply the same pattern, 6 and 5, what do you get? Well, you have to take what? 5 first. 5 is the number in the third column, so we take 5 and 6, 56. Right? However, what is given? 241. If you apply the pattern of taking the third number in the third column and number in the first column, 43, that is okay for the first number here. However, that is not okay for the second set of numbers. 6 and 5, if you take 5 and 6, we get 56. But what is given here? 241. So, what is the pattern? So, this is not the pattern. What else we have? 43. Well, 3 and 4, if you take 3 and 4, multiply 3 and 4, what do you get? 3 into 4 is 12. And here it's 43. 12 and 43, is there any connection? Well, 3 into 4 is 12. 12 into 4 is what? 48. 48 minus 5 is 43. Okay, so let's try that way. 3 into 4, that is 12. Again, we multiply with a 4, we get 48. then we subtract 5. What do you get? What is 43? And if you apply the same pattern for 6 and 5, what do you do? 6 into 5, so 6 into 5, and again it must be multiplied by 4, because this case we have multiplied it with 4, so multiply with 4, then subtract 5. So 6 into 5 is 30, 30 into 4 is 120, 120 minus 5, it's 115. Alright, so that doesn't work. Or another way, 6 into 5, this case we have 3 and 4, it's multiplied by 4. So that means number in this column, we use the number in that column. So number in this column is 5. So we multiply 6 into 5 with 5. Then subtract portion. Subtract. This case 4 and this is 5. So subtract what? 5. 4, multiplied by 4 and subtracted 5. So multiplied by 5, subtracted 6. So 6 into 5 is what? 30. 30 into 5. That's 150. 150 minus 6. 150 minus 6 is 144. But what we have here is 241. We don't get the answer that way. So the approach must be totally different. What else? Anyone else? What do you have in your mind? So anybody? I'm pretty sure at least some of you have the answer. This case, you know what? The number is 6 and 5. You have to do some kind of operation for 6 and 5. Then we need to get what? 241. Well, you can do the operation on 6. You can do the operation on 5. That's not an issue. But if 11 is given, we cannot take that one separate and another one separate. You have to take it as 11 as a whole number. That's what it says. So that means you can do the operations on 6 and 3, etc. No issues. Here we have what? 241. 241 from the 6 we need to get 241. Well, if you take, 6 into 5, 30. 30 how many times is somewhere near to 240? 240, is it a multiple of 30? Think about it. 240, 24, right? 30. 24 is a multiple of 30? Yes. I mean, 24 is not a multiple of 30. 24 is a multiple of 3. That means 240 is a multiple of 30. Correct? So 240 how many times? 3 how many times? 8 times, right? 30 into 8. How many? 30 into 8? That is 240. So 6 into 5 is 30. 6 into 5 is 30. 30 into 8, 240 plus 1, 241. We got that one. How about this one? Well, 3 and 4. 3 into 4, that's 12. 12 into 8 plus 1. Because why it is 8? Because we have taken that 8 here. So, but this case, 12 into 8, how much is that? Do we get 43 plus 1? I mean, 43. 12 into 8 plus 1, do we get 43? Not at all. So, that's not possible. So, again, this pattern doesn't work. What else you have? This is how, what sometimes you see that some of the questions are really challenging or time consuming in logical reasoning part. But if you get a question like this and if you are not really getting any pattern, skip that question. Skip means leave that question for the time being. Come back to that question later if you have time. Otherwise, don't spoil your time on that difficult question. If you find it difficult, leave it. That is how you deal with a competitive exam. Okay. So this question, if I try to do this question in a real exam, if I'm not really getting the answer after doing all these operations, probably I skip this question and come back to this question later. But since we do the classroom discussion, we cannot really skip and run away from this question. We have to solve it. Okay, let's try this. 6 and we have to get near to 240, right? So what I know is 6 cube. We'll take what? 6 cube. 6 cube is 216. 216 and how much is the balance we need to get? 216 and this is 241, right? So it's pretty much 25. Yeah, we need to get 25 more. So that means 216 plus 25 is 241. Where do you get that 25? Well, here it's 5. So you take that, what, 5 square. That's 25. So pretty much the operation what we have done here is 6 cube. Where do you get that 6? 6 from here, the first column. You take the cube of that number in the first column and you take the square of the number in the second column. So 6 cube plus 5 square, what is it? It's 241. Let's apply the same pattern for the first row here. That means what? 3 cube plus and 4 square, because the number in the third column we take it as square. So 3 cube plus 4 square. How much is that? 3 cube is 27. 4 square is 16. 27 plus 16. 27 plus 10. 37. 37 plus 6. 43. Yes, correct. So this is 3 cube. That is 27 plus, we take it as what? 4 square. That is 16. And if you get that pattern for row number 1 and row number 2, apply the same pattern on row number 3 and find out what is the answer. What is it? You take the cube of number here, that is 2 cube plus, what is it? 11 square. So 11 square is 121. 121 plus 2 cube, 8. So 129. 121 plus 8, 129. So we have the answer right here, 129. Okay, let's move on. All right, so how many triangles in this figure? See that? That's an interesting question. So we are looking for any type of triangles, doesn't matter. It could be a single triangle like this, or it could be sometimes, you know what, if you combine these two figures, you may get a triangle. Let me do it. I'll just show you that. So here, you see that? Triangle 1, triangle 2, triangle 3, triangle 4. At the same time, if you combine these two figures, see that? If you combine, that means I'm just kind of removing the line in between. So if you take these two figures together, you get a triangle. If you take these two figures here, you get a triangle. So you can take those kind of combinations as well, right? So either you take one triangle alone or you take combinations like this. And if this case, you see that one triangle here, two triangles. These triangles are a combination of two small triangles. And that combinations could appear in a different way as well. So that means you can combine these two triangles. When you combine these two triangles, I'm just kind of like removing the line in the middle. So you see this? These two triangles together, you get another triangle. And these two triangles together, you get another one. So these triangles, you can count all these type of triangles. Either it is single one, individual, or it's a combination of different shapes. If you get a triangle, it's good enough. So you can count any of this. Okay, let's do the counting. How many triangles are here? The answers are 22, 24, 20 and 18. So anyhow, we know the answer is either 18 or more than that. So let's do the counting. Here 1, 2, 3, 4. So we have 4 triangles. That means 1, 2, 3, 4. Each one is a triangle. Now if you take 1 and 2 together, see that 1 and 2 together, that's a triangle. And 3 and 4 together, 3 and 4 together, that's a triangle. So we have another 2 triangles. 1 and 2 together, 3 and 4 together. And it's not the end of the story. We have already taken 1 and 2 and 3 and 4. Now we can take 1 and 3. That's another triangle, 1 and 3. Then how about like 2 and 4? Yes, that's another triangle, 2 and 4 together. So we got another 2 triangles. So 1 and 2 together, we got that 2 triangles. 3 and 4 together, we got another 2 triangles. Okay, so let me remove that combinations, or actually let it be there, no issues. We can go for another set of triangles or another color. Actually that is better. We go for another color, I would be more visible. Now I'm going to take the triangle here. Let me take a color which is more darker. All right, so this one, see this? a triangle here. There could be other figures inside, no need to worry about it. What we are looking for is a triangle. So 1, we have another triangle here. 2, well, this one, I'm going to take this one. 3, and this is the 4th one. So 4 pink triangles, 4 of them. Which are they? 1, 2, 3, 4. Whatever inside we already counted. So we got 8 of them. So now pink, we have 4 of them. Now what else we have? Let's check it out. We have this triangle right here. So this yellow one. So we have 1 here, 2, 3, and 4. So 4 yellow triangles. And that is not the end of the story. We have more. Where are they? Here. See this? Here is a triangle, and here is another triangle. So 2, then we have 3 right here, 4 right here. So 4 of them. Is there any other triangle we have missed? Check it out. So ultimately, how many here? So it's 8, and this is what, 12. So 8 plus 12, we have 20 so far. So anything we have missed? If you have missed, check it out. So what is the answer right now we have is 20. All right, next one. Select the option that is related to the third term in the same way as the second term is related to the first term. That means 16 and 69, there is a relation between 16 and 69. Same way 24 and then question mark here, they are related. And 31 and 144, they are related. So there is some kind of a relation. So we need to find out what exactly the relation there. So 16 and 69. So what is the relation there? First of all, we look at that part. 16 and 69. And next one is 24 and what? That we need to find out based on the relation between 16 and 69 and 31 and 144, we may get this 24 and what? So 31 and what? 144. So 16 and 69. 16, well, the first thing what come to my mind is 16 into 4. 16 into 4 is 64. 64 plus 5 is what? 69. So if you apply the same pattern here, 31 into 4 plus 5. So 31 into 4, how much is that? 30 into 4 is 120. 31 into 4 is 124. 124 plus 5 is 129. So this is what it's given is 144. So that doesn't work. Then what is the possibility? Anything else? Think about anything else. Well, here what I see is 31. 30 into 5 is 150, right? 31 into 5 is 155. So if you multiply that with 5, 31 into 5, 155, and this is 144. So that means into 5 minus 11. And if you apply the same pattern for 16, let's see what happens. 16 into 5 is 80. 80 minus 11 is 69. That's correct. So into 5 minus 11, into 5 minus 11. So if you apply the same pattern for 24, 24 into 5 minus 11. 24 into 5 is 120. 120 minus 11 is 109. Yes, we have the answer right here, 109. See the pattern? 16 into 5 minus 11 is 69. 31 into 5 minus 11 is 144. And if you apply the same pattern for the number 24, we get the pair for the 24 using the same pattern. So the answer what we have here is 109. Got it? Next one. This is which letter cluster will replace the question mark. So that means we are looking for the answer choice here. So we have letter clusters here: W, F, B, I, U, C, W, B, S, Z, R, U. So these are a set of letters. So that is what they mean by what? Letter clusters. This can be taken as a letter series as well, right? The clusters of letters, or well, letter series as well. So what is letter series? First of all, we take a look at what is letter series. I just give you a couple of examples, then you get a clear idea. Let's try this way. C, E, H, L. What's the next letter? What is the best way to deal with this kind of questions? The best thing what we can do here, position values of letters. If you are aware of position values of letters, that's pretty easy. Position values means A is 1, B is 2, C is 3, D is 4, etc. So C is what? 3. Position value 3. And E is 5. And H is what? 8. And L is 12. If you look at that way, what do you see right here? 3 and 5, difference is what? 2. 3, 5, then 5 and 8, difference is what? 3. And 8 and 12, difference is what? 4. So the differences are 2, 3 and 4. And next one is 12 plus 5. 12 plus 5, how much is that? 17. Which is the 17th letter? Whichever 17th letter, that's going to be the answer here. 17th letter is what? Q. So that's the answer. So that is pretty much the letter series with single letters. And if we have, let's say, two letters in each set, what happens then? We'll take a look at that. Let's say AC, DG. I'll make it as H and L. HL. Then next one would be M and R. So what's next? Do you see any pattern here? Well, A and C. After C, next letter D right here. Then D and G. After G, next letter H is here. Then after H and L, the next letter after L is M. That's here. So M and R. After the R, the next letter is going to be which one? S. So the first letter of the answer is S. And anything else is missing here? Second letter. How do you find the second letter? 1 and 3. So 1 plus 2 is 3. D and G. D is fourth letter, G is seventh letter. So 4 plus 3 is 7. And 8 and this is 12. L is 12. So 8 plus 4 is 12. And this is what? 13. 13 and 18. So 13 plus 5 is 18. So if you mark the differences, if you see that this is 2 and this is 3, 4 plus 3 is 7, and this 8 plus 4 is 12, and 13 plus 5 is 18. So next one must be, this is 19. So 19 plus how much? The difference is 2, 3, 4, 5. 19 plus 6. 19 plus 6, how much is that? 25. So 25th letter. So 25th letter is what? Y. That's one way of looking at this question. There's another way of looking at this question. I'll show you that. Let me write these numbers here. Letters here. A, C, D, G, H, L, M, R. Another way of looking at this letter, probably you must have noticed this already. Look at the first letters of each set. Just the first letters of each set. That means 1, this is 4, this is 8, this is 13. What's the next letter? So 1 and 4, the difference what you see here, 1 and 4 difference is 3. And 4 and 8, the difference is 4. 8 and 13, the difference is 5. So the differences are 3, 4, 5. Next one would be 6. So 13 plus 6, how much is that? 19. So 19th letter, S. So we got the first letter of the answer. Second letter, C, G. C is what? 3. C is 3. G is 7. And this is 12. And this is 18. So 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. 18 plus 7. 18 plus 7 is what? 25. So 25th letter, that is Y. So SY. So that's another way of finding the answer for these kind of questions. So again, we call it a cluster. A and C together is a cluster. D and G is a cluster as well. That's a similar type of question we have given right here. So let's look at that question. W, F, B, I. U, C, W, B. U, C, W, B. And S, Z, R, U. Now we are looking for the answer. Let's look at the first letters. W, U. W is 23, U is 21. So this is 23, this is 21. So minus 2. And this is 19. So again, 21 minus 2. So it is minus 2, minus 2, minus pattern. So S minus 2. That is 17. 17 is what? Q. So if you have only one answer choice starting from Q, that would be the answer. But this case, you know what? All the answer choices are starting from Q. So we need to get the second letter. So what's the second letter? Second letter, here we have F. F is 6, right? F is 6. And here the second letter is C, that is 3. So 6 minus 3 is 3. Then 3 minus 3 is 0. 0th letter is Z. How do we get 0th letter Z? Okay, that's interesting. I'll show you that. Take it this way. A, B, C, D, X, Y, Z. And after this, X, Y, Z, you know what? This is 24, this is 25, this is 26, and it continues. So, well, if it continues, it like this. So, well, after 26, 27, 28, 29, etc. It's a never-ending process. It still goes on. And how about this way? This side, 1, 2, 3, 4, 5, 6. It goes towards right hand side. At the same time, it's something like number line. So what happens towards the side? There could be a letter, 0th letter, minus 1, minus 2, etc. Which is the letter before A? Look at this. This is 27. A can be 27. A can be 1 as well. So if A is 27, the letter before A is what? Z, 26. Similar way, the letter before A, what could be Z? And before Z, that could be Y. And it could be X. And it could be W. And that's the way it is. So, if you need to get the 0th letter, which is the 0th letter? Z. So C can have the value 0. And then now 0 minus 3 or Z minus 3. So which is the letter? Z minus 3. If you take Z as 26, 26 minus 3, 23. You can take it as 23rd letter as well. So what is it? That could be W. So the second letter for the answer must be W. You got it? 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3. That means naturally it is what? Minus 3. Minus 3 is going to be W. So QW. How many answer choices with the QW? Answer choice A and answer choice C. So that means answer choice B and answer choice D. These two answers cannot be the correct answer. Now we have to take the third letter. Third letter, these two. When you look at A and answer choice A and C, third letter, here it's M, here it's N. M or N. So if you get the third letter, we get the final answer. We don't need to go for the fourth letter. So look at the third letter. It's B, and this is W. Okay, B, W, R. So what is it? B, if you take it as what? Position value of B, if you take it as 2, what happens then? This is 2. And this is 23. W is what? 23. Third letter in each set. And how about this is 18? How about this R, right? So R is 18. So 23 minus 5 is 18. How about like 2 minus 5 is 23? No way. At the same time, you can see that B can have a position value what? 28. So B can have the value either 2 or 28. So if you take the value for B as 28, position value as 28, so 28 minus 5 is what? 23, correct? And 23 minus 5 is 18, good. So 18 minus 5 would be 13, 13 the letter M. So the answer would be QWM. So this cannot be the answer, this is the answer, QWM, and the last one N, naturally, because there is no other answer with Q, W and M. So this would be the answer. You don't need to check the last letter. So answer choice A. So this is how we find the pattern. You need to really look for the pattern. Once you get the pattern, it's pretty easy for you to go forward and find the answer. That's the way you deal with this kind of questions. Number series questions, actually, they say it is, letter cluster, fine, but each one is a series. You see that? All the first letters in a series, all the second letters in a series, all the third letters in a series. That's the reason they have used the word series here. Now let's go for next question. Again, similar type of questions we have seen earlier. The second number in the given number, the second number in the given pair. Okay, they repeat that given many times, right? Pair is obtained by performing certain mathematical operations. So pretty much what? 16 and 1024, there is a relation. 14 and 784, there is a relation. 18 and 1620, there is a relation. And 12 and 576, there is a relation. So we need to find out that relations, and what we need to do, the same operations are followed in all the number pairs except one. That means one pair is different. 3 pairs will have the same type of operation and one pair is different. Find that odd number pair. That means odd number means we are not looking for like 1, 3, 5, not that odd number. Odd number means the one which is different. Probably you heard this usage, odd one out. That is what exactly we do here, odd one out. Odd one out means not really finding the odd number out, finding the number or a pair of numbers or a set of numbers which is different from other groups. So here we have like 4 pairs. See that? First pair, second pair, third pair, fourth pair. Out of that 4 pairs, one is different. We need to find that which pair is different from other pairs. First of all, we need to look for the patterns. So what are the patterns here? First one is 16 and 1024. 16 and 1024, is there a connection? What is 1024? How about like 14 and 784? 14 and 784. How about 12 and 576? 18 and 1620. 12 and 576. We'll start from the smallest number here. Smallest number is 12. So let's start from 12. 576. 12 and 576. Is there a connection? What is 576? 576, what come to my mind is 24 square. Okay, 576 is what? 24 square. And how about the other numbers here? Are they squares? How about 1024? That's 32 square. How about 784? That's 28 square. Alright, so this is 12 and this is what? 12 into 2 is 24. 24 square is 576. So 12 into 2, 24. 24 square is 576. Same way, 16. 16 into 2 is 32. 32 square is 1024. Alright, now 14. 14 into 2 is 28. 28 square is what? 784. And 18. 18 into 2, 36. What is 36 square? Is it like 1620? 1620. What is 40 square? 40 into 40, 1600, correct? So 1620, it's something more than 40 square. So 36 square must be something less than that. So 36 square is not 1620. So that means that pair is different from other pairs. So which is the answer? This one. 36 square. Well, 18 into 2 is 36. 36 square is 1296. Is it? 36 square. Check it out. Check it out. So that is pretty much, you know what, a brainstorming exercise for you. Find out the square of 36 without doing the conventional calculation. Do the mental calculation and find out what is 36 square. Anyway, 36 square is not 1620 because it's 40 square is 1600. So this 1620 is a square more than 40. What we are looking for is 36 square. So that is the one which is different from group. All others, there is a pattern. However, for this pair, and that pair doesn't follow that pattern. Here it is. What is it? A denotes plus. So that means this is symbols and notation type question. There are wide varieties of questions in logical reasoning. This is symbols and notation. What we are trying to do here, or what we are supposed to do here, 13 and 12, each letter is here. That letter is represented, or that, you know what, letter represents a mathematical operation. So B denotes what? Multiplication. So 13 into, so B means multiplication, 13 into 9. What is it? D. D denotes what? Divided by. So 13 into 9 divided by 3. And then A. A means addition. And then bracket. 14. 14 and D means what? Division. So 14 divided by 7. And then again B. B means what? Multiplication. 6. And C. C means what? Subtraction. So C subtraction. Then we have what? 21. Again we have A, that is plus. Then we have in the bracket 32. 32 and B is what? Multiplication. 32B. This is what? So apply BODMAS. BODMAS, bracket first. Then off. O means off. Off means to the power. Is there any power related questions here? That means 2 square, 3 square, 4 square. Any squares here? No. Squares or cubes? No. There is no power related. So bracket we have. Then BODMAS, B-O-D. D means division. So first bracket. O is not here. So the next operation is D, division, then multiplication, addition and subtraction. So let's do the bracket first. This is 13 into 9. Or you can take it this way. When you simplify it, you take all this together. 13 into 9 divided by 3. Or 13 into 3. 9 by 3 is 3. 13 into 3, 39. So we get 39, this part, plus 14 by 7 is 2. 2 into 6, 12. Minus 21 plus 32 into 2, 64. This is what we have here. Then do the addition and subtraction. So this is pretty much what? 64 plus 12. How much you get? 64 plus 12. 76. So we have 76. And 39 and minus 21. 39 minus 21. Well, 39 minus 20 is what? 19. So 18. You get 18. 76 plus 18. 76 plus 20. 96. So 76 plus 18 means 96 minus 2. So that's 94. So the answer right here, 94. So this is pretty much mental calculation type question. Nothing complicated. Just apply the board mass what you have studied in school level, in class 7th or 8th. I think it is even before that, board mass. You must have learned that, right? So that's what it is. Just a mathematical operation. These type of questions, why do they ask this type of questions? They need to just check out your attention for simple things. So you don't get confused with the numbers when you do the multiplication, when you do the arithmetics, different operations here, right? So you don't lose your concentration. That is pretty much a check for attention to the details. So minor details, even minor little things are here. So attention to the minor details. Next question. Okay, again, looks like a number series question, right? Which of the following number will replace the question mark in the given series? So it's pretty much a number series question. Let's look at that. 19, 38, 35. Then we have a question mark. So we have a blank space. That means another number is supposed to be here. Then we have 135, 810. Okay, so what is it? 19 and 38. What are they? 19 into 2 is 38. That looks interesting. 19 into 2 is 38. And 38 and 35? Well, that difference is what? 3 minus 3. Into 2 minus 3. And 35 and what? 35 and something must be the answer here. Look at the answer choice. We have 146, 142, 137, 140. So the least number among the answer choice is 137. So here what we are getting, the answer must be either 137 or more than 137. So it's pretty much, 35 into some kind of a multiplication. If you add numbers, that may not work that way. So 35 into something, how much? 35 into 2, here 19 into 2. 35 into 2, 70. It comes around 70. So that doesn't work. So 35 into 3, again it's 105, right? 35 into 4, that is 140. Okay, so we have an answer 140 here if it is 35 into 4. We are not 100% sure about that pattern, but we are trying it. So if it is 35 into 4 is 140, if the number 140, then this is 135. So that means it is minus 5. So look at the pattern. Into 2, minus 3, into 4, minus 5. Next must be into 6. So 135 into 6 is 810. Well, 135 into 6, how do you find it? 100 plus 35 into 6. 100 into 6, 600. 35 into 6, 35 into 2, 70. 70 into 3, 210. Well, 35 into 6 is 210. So 100 into 6, 600. 600 plus 210, that is 810. Answer is correct. So this is the pattern. Into 2, minus 3, into 4, minus 5, into 6. So if you apply that pattern, the answer what we are getting here is 140. So the answer for this question is 140. Right, next one. This is another interesting type of question. Select the option that is related to the fifth term in the same way as the second term is related to the first term and the fourth term is related to the third term. Ultimately, what we are looking for is like these are the pairs. First and the second term, there is some kind of relation, and second and third one, there is some kind of relation. So similar way, we need to find the third one and what is the term supposed to be here. Set of letters supposed to be here based on the same pattern. So let's look at the pattern here. Number is UNNYRE. So number we have, U and N are here. Then we have NY. So here there is no Y, here there is a Y. So that means these questions comes under the category pretty much coding, decoding type questions, because you know what? Well, some of the letters here, M and B, those letters are represented by N and Y. Because you know what? The Y is not here. If Y is here in the original word number, then you know what? It's a rearrangement. But Y is not here, so it means it's not a rearrangement. Again, you know what? Other letters are fine. Look at this mother. So mother, M-O-T-H-E-R, these are the letters. Here we have M and O, that's fine. But G, that letter G, it is not here. That means it's a foreign letter right here. So foreign letter representing any one of this letter here. Foreign letter means the letter which is not in this mother. So that means that's pretty much coding type question, coding decoding type question. So how do we answer coding decoding? Let's take a look at it. This is what it is. Number, let's find the code for this number first. So number is coded as what? UN, NY, and RE. So what is happening here? Each letter, it's called as like NU, UN. What is happening? Actually, NU, these two letters, it's given as UN. So that's pretty much those two letters are reversed. So we'll take them as a separate cluster. NU and UN. So they are reversed. Same way ER and RE, they are reversed. However, MB, M and B, if it is reversed, it must be B and M. But actually it is given as what? N and Y. Why it is? So we need to look for the pattern which is given for us. So here it is, M is 13, position values, this is 2, and here it is what, 14, and here this is 25. You know what? When you look at these letters A, B, C, D, etc., E, F, let me write it, you know what, in a little more spacious way, so then you get the clear pattern. So let's do this way: A, B, C, D, E, F, G, H, I, J, K, L, M. So these are the first 13 letters of English alphabets. 13 letters, total 26. First 13 letters are here. Now, the next letter, N, I'm going to write it in a different pattern. That means I'm just reverse it. N, O, P, Q, R, S, T, U, V, W, X, Y, Z. You see what is really happening here? These are known as complementary letter pairs. A is 1, Z is 26. A is the first letter from the left end and Z is the first letter from the right end. When you write A, B, C, D, E, F, G up to Z or up to Z, A is the first letter and Z is the first letter from the end. And B is the second letter, Y is the second letter from the right end. So that is 25. And C is the third letter from the left and X is the third letter from the right end. So that's 24. That is and these letters are known as complementary letters. The first from the left and first from the right, second from the left and second from the right. So there is a peculiarity for these complementary letters. It's easy for you to find out. There is no need to write it this way. Always the complementary letters, the sum of the complementary letters would be what? 27. Here it's 1, here it is 27. 1 plus 26, 27. 2 and 25, 27. 3 and 24, 27. This is 4 and 23, 27. 5 and 22, 27. See that? And that is exactly happening here. M is the 13th letter from the left end, and from the right end, when you just write it in a single line, N, O, P, Q, etc. From the right end, N is the 13th letter. Or 13 plus 14, you see that it is 27. Same with 2 plus 25, it is 27. So these are the complementary letters. So ultimately, what is the method, coding method used here? The first two letters are reversed, last two letters are reversed, then the middle two letters, the complementary letters for the middle two letters are given. And is it exactly for mother? Let's check it out. Or they use the same pattern. So for mother, the pattern, the code which is given as OMGSRE. OMGSRE. So here, M and O, that is reversed O and M. The last two letters, E and R, is reversed R and E. Perfectly all right. Now T is the 20th letter and G is the 7th letter. So 20 plus 7, 27. So if they are complementary letters, sum of their position values must be 27. So 20 plus 7, 27. Perfectly all right. This is 8 and S is 19. Position value of S is 19. Because T is 20, S is the letter before that, immediately before that, ST. So S must be 19. So that 19 and this is 8. H is 8. G is 7. H is 8. So 19 plus 8, it's again 27. So these are complementary letters. Perfectly all right. So that means we need to follow the same pattern here. What's the same pattern? This is what? F and I, you have to reverse it, right? So IF. How many answer choices with IF? Well, all the answer choices with IF. So we have to find the other two letters. So then after IN, then N and G. Sorry, after F and I, we have N and G. N and G, what is a complementary letter for N? N is 14. 14 plus how much is 27? 13, right? So that must be M. N, complementary letter, M. G, complementary letter, G is 7. So total must be 27. So 7 plus 20. 20 means T. So MT. Then ER. ER must be reversed. RE. So RE. Okay, so IFMTRE. IFMTRE. So the answer choose C. So question number 11, answer is what? C. So this is pretty much a coding decoding pattern. We call it coding decoding. Coding decoding, we have several varieties of patterns. So when we come across those kind of questions, definitely I'll explain those different types of patterns from that area, not right now. In a certain code language, advisory is written as BFYMRMOU, advisory. So again, looks like a coding decoding type question. So let's take a look at that. How this advisory is coded? Advisory. It's coded as BFYM RMOU. Let's take it this way. So position values. Position value is 1. So A is 1, D is 4, this is what, 22, and this is 9. Well, this is 19, and this is 15, and this is 18, this is 25. How about BFY? So 2, 6, and this is 25, and this is 13, 18, 13, and this is 15, 21. And the position values of letters, if you know the position values, that's going to be really easy for you to deal with this type of questions. Alright, anyway, A and B what? A is called as B, so plus 1, we'll take it as what? Plus 1. And D plus 2 is F. And B, 22 plus 3 is 25. And 9 and this is 13, so plus 4. 19 and 18, that's minus 1. And 15 and 13, that's minus 2. And 18 and 15, that's minus 3. And 25 and 21, minus 4. So look at the pattern. Plus 1, plus 2, plus 3, plus 4, minus 1, minus 2, minus 3, minus 4. Interesting. And champion is written as D, J, D, Q, O, G, L, J. So you don't need to really check all those, given letters and their codes. But just try this. C plus 1 is D. H plus 2 is J, A plus 3 is D, and M plus 4 is Q, and P minus 1 is O. So that's a similar pattern. So that means that we can go straight to designer to find the answer. So designer, let's write it down, designer. Designer, how do you do it? Same pattern. We apply the same pattern here. What's the pattern? This is what? Plus 1, plus 2, plus 1, plus 2, plus 3, plus 4. And this one, minus 1, minus 2, minus 3, minus 4. When we do it, what do you get? D plus 1. D is 4. 4 plus 1 is 5. E is 5. 5 plus 2 is G. E, G. And S is 19. 19 plus 3 is 22. V. And I is 9. 9 plus 4. 9 plus 4 is 13. M. And G is 7. 7 minus 1. F. N is 14. 14 minus 2 is 12. L. E is 5. 5 minus 2. 5 minus 3. That is 2. That is B. And R is 18. 18 minus 4 is 14. 14 is what? N. So E, G, V, M. E, G, V, M. How many answer choice with E, G, V, M? There is only one answer choice. E, G, V, M, F, L, B, N. F, L, B, N. That's the answer. So we have the answer choice C. Next one. Select the option that is related to the fifth number in the same way as the second number is related to the first number. Okay, so that's similar to what we have done earlier. So here is like, there's a pair, so 24 and 1 minus 122, there is some kind of a relation. And 31 and 248, there is some kind of a relation. And using the same kind of relation, we need to find minus 18 is to what? So we need to find the number here. The answer choices given are minus 152, minus 146, 148 and 144. So 2 minus negative numbers and 2 positive numbers among the answer choices. So which is going to be the answer? First of all, we need to find the pattern. 24 is minus 192. And, well, 31, minus 31. Minus 31 is what? 2 plus 248. And next, minus 18 is given. Minus 18 is to what? That's the question we have. So 24 and 192 is the relation. 31 and 248 is the relation. Well, first of all, if you may take the differences like 24 and 192, do we get a constant difference? Well, it looks like, 24 and 192, the difference what you get is 168 is the difference what we get here. Here 248 minus 31, you don't get 168 in this case. So that is not the constant difference case. How about like 24 is a multiple of 192. So 24 is multiplied by something, do we get 192? 31 is multiplied by something, do we get 248? Let's check it out. 31 into something is 248. 31. Well, 243 into 30 into 8 is 240, correct? So 31 into 8, 248. Okay, so 31 into 8 is 248. Here it's minus 31. Minus 31 into minus 8. What do you get? Plus 248. Okay, if you apply the same thing here, 24 into minus 8. So if you multiply with minus 8, here we multiplied with minus 8. Here we are multiplying with the same constant minus 8. So 24 into minus 8. Is it minus 192? Well, minus sign is there. 192. 24 into 8. Well, 24 into 4 is what? 24 into 4 is 96. 25 into 4 is 100. 24 into 4 is 96. So 24 into 8 is what? 96 plus 96. 96 plus 96. 90 plus 90? 180. 6 plus 6 is 12. 180 plus 12? 192. Perfect. So that means 24 into minus 8 is 192. 24 into minus 8, minus 192. Then minus 31 into minus 8, 248. Okay, so we multiply minus 18 with what? Minus 8. So the answer what we are getting is going to be a positive number. It's not going to be a negative number. So positive number, 8 into 8 is what? 8 into 8? 64. So the last digit of the answer is going to be 4. So here among the positive numbers, there is only one number is ending with 4. Unit digit only for one number, 4. So 144 is going to be the answer. Even without multiplication, you can get the answer 144. If you really want to multiply this way. Multiply 20 with 8. 20 into 8, 160, right? However, we don't need 20. We need what? 18. So 20 and 18, that difference is what? 2. So 20 minus 2. 20 minus 2 into 8. So 20 into 8, 160. Then minus 2 into 8, or 2 into 8 is what? 16. So 160 minus 16 is 144. That's the answer. Alright, so that's positive. Negative, 2 negatives, multiply 2 negatives, you get a positive number. So 144, that's the answer right here. Okay, next one. Which of the following letter clusters will replace the question mark in the given series? So that's similar to what we have done earlier. Letter series type question. Letter series question. Just write it. W, V, E, U, T, G, S, R, I, O, Q, P, K. Q, P, K. So what do you get? Take the first letters of each set. So W minus 2 is U, U minus 2 is S, S minus 2 is Q, Q minus 2 is what? O. Q is 17, O is 15. So how many answers starting from O? Only one answer choice is starting from O. So that is going to be the answer. You don't need to check out the second letter or the third letter. Even without that, you get the answer. If you really want to check it out, exam point of view, you don't need to do that. But just a practice purpose, if you want to check it out, just try that. V is 22, T is what? 20. So minus 2 and T, this is 18. So again minus 2. R minus 2 is P. P minus 2 is N. So O-N. Look at that. Second letter is correct. O-N. And the last letter, E, G. E is 5, G is 7. So plus 2. E, G. Let me take another color for that. Well, E, G, I. So E, G plus 2, I. I is 9. 9 plus 2 is 11. 11K. So K plus 2 is what? 13. 13 is what? M. O-N-M. So O-N-M is the answer. And here select the correct mirror image of the given combination when the mirror is placed and MN. So this is what the mirror is. So mirror is placed right here. So what's a mirror image you get? So it is exactly like when you look at a mirror, right? So what you see, if you place something, a letter or whatever it is, if you place near the mirror, what you see in the mirror. So this is going to be 3 must be like this, inverted. So it is horizontally inverted. And K would be like this. Or you just write it on a piece of paper and place it near the mirror. It is possible when you are at home, but it is not possible in the exam hall. Okay, so this is just for the practice purpose. You can write it also on a piece of paper and place it near the mirror. So that's K, this is 2. 2 would be like this, the mirror image of 2, and 8 would be exactly like that, there's no difference, and H would be like this. And this is T. So which is going to be the answer? The answer is going to be T. This is 2, 8, H and T. That's the answer choice what we have, A. In a certain code language, so it is pretty much coding decoding type. Usually the coding decoding type question, if it starts within a certain code language, that's a coding decoding type question. Some of the questions, they may not give you this phrase here in a certain code language. Still that question must be coding decoding question. We see that type of question earlier. They haven't mentioned about like code language, but still that question was coding decoding question. This is definitely a coding decoding question. So, well, this is certain code language. Kitchen is written as LHUBIDO. So what is the pattern? Once it is coding decoding question, look at the pattern. Kitchen. LHUBIDO. LHUBIDO. So, try this. This is 11, this is 12, 9, and this is 8. This is 20, this is 21, and this is 3, and this is 2. 8, 9. So, what is the pattern? What we are looking for the pattern here, that is simple pattern. This is plus 1. 11 plus 1 is 12, 9 minus 1 is 8, 20 plus 1 is 21, and 3 minus 1 is 2, 8 plus 1 is 9, and E minus 1 is D, and N plus 1 is O. So it's plus 1, minus 1, plus 1, minus 1. That's a pattern. And if in that case, you see that husband is written as ITT, H plus 1 is I, then next one is U, U minus 1 is T, so that's a similar pattern. So once that pattern is confirmed, how will the word element is written in that language? Element. So let's try the element. E plus 1. So you have to follow the exact pattern. So the first one must be plus 1. Next one must be minus 1. So E plus 1, F. L minus 1, K. And again, E plus 1, F. M minus 1, L. F. And N minus 1, that is M. So F, K, F, L, F, M. F, K, F, L, F, M. So this is the answer. Last one is going to be U plus 1. Plus 1 is U. So ultimately that is the answer. So it's pretty much, you know what, follow the pattern, you get the answer. In a certain code language, again that's a coding decoding type question. Famous is written as AFOMSU. So let's check out the pattern. What is the pattern here? Famous. AFO, A, F, O, M, S, U. So what is happening here? That means what type of decoding method is used here? Look at this. F and A, that is A and F. First two letters are reversed. Then M and O, O and M. Second two letters are reversed. Then U and S, S and U. The last two letters are reversed. And finger is written as, so finger FI, IF. NG, GN. So that's the same method. So if that's the case, find out invest. Invest. Invest, you have to reverse the first two letters and the second set of two letters. That's the way it is, right? So IN, it must be NI. VE, EV, ST, TS. So NI, EV, TS. NI, EV, TS. So this is the answer, the last one. NI, EV, TS. Okay, we have this question right here. That's 18, question number 18. 3 statements are given followed by 3 conclusions numbered 1, 2, 3. Assuming the statements to be true, even if they seem to be at variance from the commonly known facts. That's something, an interesting direction you may see here. Seem to be at variance from commonly known facts. What's the meaning of that? Do you have any idea? What type of questions it is? What type of question? Pretty much these questions, these type of questions, when you look at that, you see the statements and you see the conclusions, and what you're supposed to do, decide which of the conclusions logically follow from the statements. So if you see the statements, something like some, all, and well, some not, those kind of statements, this is pretty much deduction or syllogism type questions. What is the deduction here? Even if they seem to be at variance from commonly known facts. So what do you have to do? Assuming the statements to be true. Assume that all the statements are true. Here, first statement is given as some butters are honey. Butter and honey, it's two different things, right? Is there butter, honey? Can we say that some butters are honey? Well, if you apply your common sense, in real world, butter is not honey. However, what it is given to us, direction, even if they seem to be at variance from the commonly known facts, you assume that the statements are true. So we take the first statement, some butters are honey, true. Don't question that statement. That's what meaning of this direction. Second one, some honeys are breads. Well, we use honey to eat bread. That's correct. But some honeys are breads? No way. And all breads are jams? Not at all. Bread is not jam. Jam and bread are different. However, we don't need to question these statements. Statements are always correct. Now what we need to check out, whether these conclusions follow the statements or not. That's what we are looking for. How do we check it? The best method to deal with these kind of questions is Venn diagram approach. We need to draw the Venn diagrams for the given statements. How do we draw it? Let's start from all statement. If you start from all statement, that is more convenient. Well, you can start from the first statement, some statement. There's nothing wrong with that. But it is, you know what, it's easy or it's more convenient if you start from the third statement. This is the third statement. All breads are jams. All breads are jams. So we draw it something like this. These are breads. This is a diagram for breads. All breads are jams. That means all breads must be inside what? Jams. All breads are jams. And second statement, well, we can take second statement or third statement, doesn't matter. However, here we have bread and jam. Second statement, if you take it, we can see that honey and bread. So there is a common element, bread. So we can take it this way, some honeys are breads. So some honeys are bread. And bread and honey, there is an intersection. Some breads are honey or some honeys are breads. So that means we draw like this. There is an intersection between honey and bread. So some honey are breads. At the same time, you see that since that bread circle is inside jam circle, honey when the honey intersect with the bread, honey intersect with the jam as well. And well, we have drawn the diagram for the third statement, second statement, and the first statement. Now next one is the first statement. Some butters are honeys. Some butters are honeys. Well, this is honey. This is what? Bread, right? So all breads are jams. This is bread. And now we have the first statement. Some butters are honeys. Some butters are honeys. So honey and butter. This is butter. This is bread. So this is the basic diagram. We call this diagram as the basic diagram. So diagram with a minimum overlap. So that is the basic diagram. Well, once you get the diagram, you need to look at the conclusions. How do you check the conclusions? Some jams are honeys. First conclusion, some jams are honeys. Look at that. Some jams are honeys. Yes, look at the diagram of jams. I use a different color for that. Some jams are what? Honeys. So honey and jam, they are intersecting. So some jams are honeys, it's correct. So that means this conclusion follow the statements. Statements are represented by the diagram. For that diagram, some jams are honey is correct. So ultimately, the first conclusion follow the statements. Second one, all honeys are butters. Well, some of the honeys are butters, but all honeys are not butters. So, well, the second conclusion is not valid for the diagram. Well, diagram represented by the statements, correct? So, well, if all honeys are butters, it's not valid here. That means the second conclusion doesn't follow the statements. So, all honeys are butters, all honeys are not butters here. So, it is invalid, doesn't follow. A positive conclusion, invalid, it doesn't follow. A positive conclusion, if it is valid for the diagram, it follows. What we need to find out, whether these conclusions logically follow the statements. And the third conclusion, some jams are butters. Some jams, look at the jams. Some jams are butters. There is no intersection between jam and butter. According to the given diagram, well, diagram is drawn based on the statements. So according to the diagram, we have some jams are butters is invalid. Jams, it's not intersecting with the butters. So, well, this is the third conclusion is what? Invalid. So, it doesn't follow. So, ultimately, what you have here? Only one follows. Only conclusion one follows. So, the answer is what? Only one follows. That would be the answer. Now, you may have some of the confusions in your mind. How do we draw the diagram for other type of statements? In deductions, there are 4 standard statements. One of the statement is all statement. Second one is some statement. So all, some. Then we have no statement and some not statement. There are 4 types of standard statements in deductions or syllogism. These statements are all, some, no, and we have some not statement as well, some not. We'll just write some examples here. All monkeys are donkeys. So that's an all statement, example for all statement. How do we draw the diagram for all statement? It's pretty simple. All monkeys are what? Donkeys. So we have drawn the diagram for all statement earlier. That's the same method for drawing diagram for all statement. How about some diagram? Some monkeys are donkeys. Some statement, always draw the diagram this way. There must be an intersection between monkeys and donkeys. Monkeys and donkeys. It's a partial intersection because some monkeys are donkeys. Not all the monkeys are donkeys. Some monkeys are donkeys. Now, no statement. How do we draw the diagram? No monkeys are donkeys. No monkeys are donkeys. Well, monkey diagram. Then we have donkey diagram. no monkeys are donkeys. That means there is no intersection between monkeys and donkeys. In order to make sure there is no intersection, we put an arrow in between. This arrow indicates that these two diagrams are not supposed to intersect because there is no intersection between monkey and donkey. No monkeys are donkeys. And the last statement what we have here is some monkeys are not donkeys. Well, let me write it down here. Some monkeys are not donkeys. So 4 types of statement. First one is all statement, all monkeys are donkeys. Second, some statement, some monkeys are donkeys. And third, no statement, no monkeys are donkeys. And the last one, the 4th type is some monkeys are not donkeys. So this is known as some not statement. The first one is known as all statement. All statement. Second one is some statement. This is no statement. This is some not statement. Some not. So how do we draw the diagram for some not? This is what it is. Some not statement. Some monkeys are not donkeys. Some monkeys are not donkeys. Well, if it says some monkeys are not donkeys, does it really mean that the other monkeys, some monkeys are not donkeys? How about the other set of monkeys? Are they donkeys? Well, some students are not stupid. Does it really mean that all other students are stupid? Not necessarily. Some students are not stupid means, well, other students would be genius. Right? So, similar way, some monkeys are not donkeys. Does it really mean that all other monkeys are? That means some monkeys are not donkeys. However, so here we have, let's say, 40 monkeys. Some monkeys are not donkeys. That means 10 monkeys are not donkeys. How about balance 30 monkeys? Are they donkeys? Not necessarily. They could be donkeys and they may not be donkeys. So we are not really sure about that. So how do we draw the diagram for that case? That case, you know what? We cannot really draw that intersecting diagram. If the diagram, monkey and donkey, if you draw the intersecting diagram like this, that means some monkeys are not donkeys. However, the balanced monkeys are donkeys. But when it says some monkeys are not donkeys, it doesn't mean that some monkeys are not donkeys and the balanced monkeys are donkeys. It doesn't mean that way. So here we cannot have the intersection between monkeys and donkeys. Right? However, we don't put the space arrow here. Space arrow means these two diagrams are not supposed to intersect. However, in the case of some not, we don't put the space arrow. If there is no space arrow means, well, this monkey can intersect with a donkey or donkey can intersect with a monkey. It means some of the monkeys are not donkeys. The balanced monkeys can be the donkeys. Not necessarily, but they can be the donkeys. So it's totally different from these diagrams. So some monkeys are donkeys. It's clearly some monkeys are donkeys. There is an intersection. This case, no monkeys are donkeys. Clearly there is no intersection between monkeys and donkeys. And this case, some not case, we are not sure about the intersection. It says that some monkeys are not donkeys. According to the given statement, monkeys are not intersecting with the donkeys, but they may intersect. So we'll draw the diagram this way and we don't keep the space arrow here. If there is a space arrow, they cannot intersect. That means no monkeys are donkeys. So that is what we have put right here, the space arrow right here. In this case, we don't keep the space arrow. So ultimately, this is how you draw the diagrams for 4 statements and deductions. Those 4 statements are all statement, all monkeys are donkeys, or all cats are dogs. These are the examples. And some monkeys are donkeys. This is the diagram. And no monkeys are donkeys. This is the diagram. And some monkeys are not donkeys. This is the diagram. Well, there are many other diagrams possible for all monkeys are donkeys, some monkeys are donkeys. It's possible to draw different other type of diagram. However, these are the basic diagrams. Basic diagrams means the diagram with the minimum overlap. In reductions question, we always use the diagram with the minimum overlap. It's possible to draw other type of diagrams for some monkeys are donkeys, no monkeys are donkeys. Yeah, it's possible, but we don't use that. So these are known as what? Basic diagrams. Let me write it. These are what? Basic diagrams. Basic diagram means diagram with the minimum overlap. So this is the approach for deduction or syllogism type of questions. Whenever you deal with the deductions or syllogism questions, go with this method. Next question right here. Well, it is a slightly different question than we have done so far. This is a calendar type question. Before we get into calendar type question, let me check, is there any other deduction question in this set? If we have any other deduction question, definitely we'll do that question and go back to the other questions. Well, we don't have any other deduction questions, so we'll deal with the calendar question right here. If 21st June 2007 was a Thursday, then what was the day of the week 21st June 2011? So 21st June 2007, that's a Thursday. And how about like what we are looking for is 21st June 2011. June 2011. So what kind of a day it is? First of all, what is the method to find a day of the week? So let's say today is Sunday. Which day would be 10 days after today? So think about that possibility. Well, any day. You can take any day or any date you want. We'll take an example. Let's say today it is 10th of May. 10th of May is Wednesday. And which day would be 10 days after May 10th? So 10 days from May 10 is May 20th. May 20th, which day would be that? Any idea? The best way to deal with that, well, these are just 10 days, so you can count using your hand, but that's not the best way to deal with the questions in the exam, because it's always not 10 days. Sometimes they may ask you the question, which day would be 67 days after today? So let's assume that today is 10th May, and which is 10 days after today. So 10 days means, well, the best way to deal with this kind of questions, 10 days means how many full weeks and how many balanced number of days. So in 10 days, we know that there is one full week, 7 days, plus 3 balanced days. Right? So after 7 days, so every 7th day, the same day repeats. That Wednesday, it is 10th of May. So after 7 days, that means 17th of May would be another Wednesday. So multiples of 7 or full weeks will give you the exact same day of the week. So we total 10 days. So we take what? 10 plus 1 week, 1 full week, 10 plus 7, 17. Balance we have 3. So when you reach that 17th of May, that's another Wednesday. Now from 17th to 20th, how many more days you have? 17th is Wednesday. Then 18th. 18th is what? Thursday. 19th is Friday. 20th is Saturday. That means 3 more days. And rather than this way, usually what we do, we have what, 10 days difference, right? May 10th is given, we need to find May 20th. So 10 days divided by 7. Why it is 7? 7 days in a week. So 10 by 7, what's a remainder? So 1 times 7, remainder is 3. So we are interested in this remainder. So this remainder is always help us to find the which day of the week. Here, remainder is 3. So if you do this question, look at 10th May, 10th May, and we need to go up to 20th of May. So 10 days, and what is the remainder we get when it is that 10 days divided by 7, we get the remainder 3. So that would be Wednesday plus 3. Wednesday plus 3 would be Thursday, Friday, and Saturday. So May, 20th of May would be Saturday. Or earlier, we know that 17th of May is Wednesday, so 18th of May is Thursday, 19th is Friday, and 20th is Saturday. That's fine. And how about like, if it is 10th May is Wednesday, which is 15 days after 10th May. 15 days after 10th May, that is 25th of May, correct? So how many days? 15 days. If it is 15 days, 15 divided by 7, what do you get? Remainder 1. So that 1 is the remainder. When you take 2 full weeks, we get a remainder 1. So that 1 must be added with that Wednesday. So 25th of May is going to be a Thursday. Wednesday plus 1, Thursday. And that's a similar method, which is the 67th day from today. 67th day from today. If it is 67, what do you do? 67 divided by 7, what's a remainder? $63, and what's a remainder? Remainder is 4. Well, if today is Sunday, today is a Sunday, which is the 67th day from today. So how many odd days here, or what is a remainder? Remainder is known as odd days. Odd days doesn't mean that odd number. Odd days could be 4, it could be 3, it could be 1, it could be 2, it could be 6, doesn't matter. So here the remainder is 4, that remainder is known as odd days. So in 67 days, we have 4 odd days. If today is a Sunday, 67th day would be 4 days from Sunday. So which is a 4 days from Sunday? Monday, Tuesday, Wednesday, Thursday. So if today is a Sunday, 67th day from today would be a Thursday. So that is how we do the calculations for calendars. That's a basic thing. Here, what we are looking for is 21st of June 2007 is given. We need to find out 21st of June 2011. How do we calculate it? So let's try this 21st of June 2008 first. How do we get it? So 21st of June 2007 to 21st of June 2008, that's exactly 1 year. That 1 year means how many days in an year. If you get the total number of days in an year, you can divide that with 7, and definitely we get the remainder as well. So how many days in that year? That's an interesting question, right? Well, in the planet Earth, in an year, either there are 365 days or 366 days. There are 2 possibilities. That depends on what kind of a year it is, leap or non-leap year, right? So here it is, we are starting from 21st of June 2007. 2007 is a non-leap year. 21st June 2008. 2008 is a leap year. So is it like 365 days or 366 days from 21st June 2007 to 21st June 2008? That is what exactly you have to think about. And how do you find whether it's 365 or 366 days a year? That all depends on how many days for the February. Now you look at the February here. Where is the February? We are starting from 21st of June 2007. So we start counting from 22nd of June 2007. So 23rd of June. So we take the all days in the month of June in the year 2007. Then after June 2007, we have July 2007. Then August 2007, September, October, November, December 2007. That's the end of 2007. Next year is 2008. So we start from January 2008, then February 2008. So there is a February between 21st June 2007 and 21st June 2008. That February is in the year 2008. Since February is in the year 2008, 2008 is a leap year, so February must have 29 days. So this is exactly 1 year. However, the February has 29 days. That means total number of days in that year is 366. If it is 366, if it is divided by 7, 366 by 7, what do you get? Let me write it here, this side. 366 by 7. 35, right? 35, how many times? 5 times. 35. Remainder is what? 1. Then 16. Again what? 2 times. 14. Remainder is what? 2. So for a leap year, every leap year, remember this? For every leap year, there are 2 odd days. Odd days means if the total number of days 366, if it is divided by 7, the remainder what you get is 2. That's known as odd days. So for every leap year, 2 odd days. And every non-leap year, 1 odd day. So here from 21st June 2007 to 21st June 2008, that's 1 full year. And how many odd days for that year? 2 odd days. So we'll write that 2 odd days here. 2. So definitely Thursday plus 2, Friday, Saturday. So 21st June 2008 is going to be a Saturday. Either you may write it or you may write it later, no issues. And next one, what we are looking for is 21st of June 2009. So we'll go step by step. Then after that, I'll show you how to go without these steps. So 21st June 2009. Well, 21st June 2008 to 2009. Well, there is a February in between. Where is that February? We start counting from 22nd of June 2008. Then we have July 2008, August 2008, September, October 2008, November 2008, December 2008. There is no February. February is in the next year. What is it? 2009. 2009 is a non-leap year. So February has only 28 days. That means total number of days is 365. From 21st June 2008 to 21st June 2009, total number of days is what? 365. If it is 365 days, how many is the remainder? How much is the remainder? 1 is the remainder. So that case, remainder is 1. Now we take it from 21st June 2009 to 21st June 2010. June 2009 to 2010. So again, there is a February in between. That February in the year 2010. 2010 is a non-leap year because 2010 is not a multiple of 4. So it is a non-leap year. So February has 28 days. It means total 365 days. 365 divided by 7. What's the remainder you get? You get 1 remainder. So 1 odd day. And from 21st June 2010 to 21st June 2011. Well, again, that's exactly 1 year. And February is in the year 2011. 2011 is a non-leap year. If it is a non-leap year, total number of days is 365. 365 by 7, what do you get? Remainder 1. So we have remainder 1. So from 21st June 2007 to 2008, remainder is what, 2 or 2 odd days. 2008 to 2009, 1 odd day. 2009 to 10, 1 odd day. 10 to 11, 1 odd day. So total number of odd days here. From 2007 to 2011, how many odd days? 2 plus 1 plus 1 plus 1. So it's 5 odd days. Total 5 odd days. 5 odd days from where? From Thursday. So Thursday plus 5. Thursday plus 5 is what? Friday, Saturday, Sunday, Monday, Tuesday. So the answer is what? Tuesday. Or you may do it this way. Well, Thursday plus 2, what do you get? Friday, Saturday. Then Saturday plus 1, you get Sunday. Sunday plus 1, you get what? Monday. Monday plus 1, you get Tuesday. You don't need to do that way. Take it as total number of odd days here, 5. So Thursday plus 5, what you get is Tuesday. Thursday plus 5. Thursday plus 1, Friday, Saturday, Sunday, Monday, Tuesday. That's what it is. Alright, so this is, it is a bit time consuming, right? How do we do it without taking that much of time? I'll just show you that. This is what it is. 21st June 2007, Thursday. What we need is 21st June 2011. What kind of a day it is? That's a question. So 2007 to 2011, how many years? 7 to 11. 7 plus 4 is 11, so 4 years. Out of that 4 years, 2008, the February in 2008 is going to be what? A leap year. 2008 is a leap year, so February in 2008 has 29 days. So that just 1 year has 2 odd days. All other years we have only 1 odd day. So ultimately there are 4 years. Out of these 4 years, 3 years are non-leap years and 1 year is a leap year. 1 year is a leap year. So for a non-leap year, we have 1 odd day, 3 into 1, plus for a leap year, we have what? 2 odd days, because its total number of days in a leap year is 366. 366 divided by 7, we get the remainder 2. So we have 2 odd days for a leap year. So ultimately, 3 plus 2. 3 plus 2 is what? 5. So ultimately, total number of odd days, it's 5. So Thursday plus 5. Friday, Saturday, Sunday, Monday, Tuesday. Exact same answer. So we got this answer in what? 20-25 seconds. Rather than going step-by-step method. This step-by-step method is for you to get an idea how to deal with this question. Otherwise, once you get an idea how to deal with these questions, go for this method. This is good enough for you to get the answer. Number 20. Select the option that represents the correct order of the given words as they would appear in the English dictionary. So it's pretty much arrange the words in alphabetical order. Pretty simple. So which is going to be the first one? So this is AD, 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 and this is AB. So the first one is going to be AB. So first word is going to be 4. And second word, this is the first one. And second one, all of these are starting from D, AD, 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 right? 1, 2, 3, and 5, starting from AD. So we are looking for the third letter. This is E, this is O, this is D, this is V. Well, this is already out. We have already taken that. So here, E, O, D, and V. So that means D is the letter to be, letter which is supposed to be the first when you compare 1, 2, 3, 5. So next one is going to be 3. So 4, 3. So how many answer choice with the 4, 3? Only one answer choice. So 4, 3, 1. So 1 is what? Adequate. Then we have 2, that is adoption. And then we have 5, advertisement. So this is the answer choice. It's a simple question. Just look at the order, you get the answer. The second number in the given pairs is obtained by performing certain mathematical operation on the first number. The same operations are followed in all the number pairs except one. Find that odd number pair. You remember we have done this question earlier, similar type of question earlier. We need to find odd one out. So how do we find it? We need to find the pattern for that. Let's try the pattern. 361, 332. 361, 332. So what's the difference? Or is there anything else? 361 is 19 square. 332, it's not a square at all. Then 533 and 504. And how about 440 and 411? 440, 411. And 525, 481. 520, 481. Any idea how to deal with this? If you take the differences, 361 and 332, how much is the difference? 29 is the difference. That difference is what? 29. And 533, 504. 504 plus 30 is 534. This is 533. So again, 29. Difference is what? 29. And 440 and 411. 411 plus 9 is 420. 420 plus 20. So that's again difference is what? 29. And here what's the difference? Well, it is 20 plus 19. That's 39 is the difference. So if you look at that way, 29 is the difference here, 29 is the difference here, 29 is the difference. So here 39 is the difference. So which one is different from the group? 520, 481. So that is what exactly we are looking for. Find that odd pair, odd number pair. That means, well, same operations are followed all the number pairs except one. So we need to find that which one is different from the group. So that different from the group is the last answer choice. Number 22. Select the correct combination of mathematical signs to replace the signs and balance the given equation. Alright, so how do we do it? 14, that is a star. Instead of star, we need to have any one of this mathematical operation here. 14, well, if you apply the first answer choice, then 14 into 5 minus 41 equal to 76 plus 35. And if you apply that, if you get an answer, or if you get the equation correct, that would be the answer choice. That would be the correct answer choice. If you don't get it, go for the second answer choice. Ultimately, this is a trial and error type of question. So how do we do it? No shortcut method. Here we have to do it as quick as possible with each question. So we apply the answer choice 1. These symbols for 14 into, so this is the first one, into 5 minus 41 equal to 76 plus 35. Now take a quick look at this. 40 into 5 is 70. 70 minus 41, that is 29. So 29 is equal to 76 plus 35. Absolutely not going to happen. So first answer choice is not correct. Now we'll go for second answer choice. Second answer choice 14. Again, second answer choice, when you apply 14 into 5 plus 41 minus 76 and equal to 35. So 14 into 5 plus 41 minus 76. 14 into 5 is 70. 70 minus 76 minus 6. Minus 6 and 41. Well, 41 minus 6 is 35. 35 is equal to 35. So left hand side, what do you get? 35. Right hand side, what do you get? Is 35. Perfectly all right. So what do you get? This one. second answer choice is correct. Once you get the second answer choice correct, you don't need to check C and D. Don't waste your time. Exam point of view, don't waste your time on these two answer choices. But if you want to practice, when you sit at home, if you want to practice, try these answer choices and check it out whether you get the correct answer or not. All right, next one. 23. In a certain code language, R is coded as 87. So this is coding decoding type of question. Note is coded as 4197. How will cat be coded in that language? So let's take a look at that. R, A-R-E. R is coded as 87. So the letters are coded as a number. So the first thing we need to do in this kind of questions is look at these letters and how you get a number from the letter. Maybe position values, right? 1, 18, and 5. 1, 18, and 5, do you get 87? If you add it, 18 plus 1 is 19 plus 5 is 24. 24 and 87, is there a connection? I don't see the connection there. How about like the other one? Note is called as 4197. Let's try that. N-O-T, note 4197, 4197. So that's a relatively large number. This is just 87. This is 4187. What are the position values? The position values of these letters are N is 14, O is 15, and T is what? 20. How do we get that 4197 from this 14, 15, and 20? Since it's a large number, look at the possibility of multiplication. So if you multiply these numbers, 14 into 15 into 20. 14 into 15, how much is that? 15 into 15 is 225. 14 into 15 is 210. Well, 210 plus 20. 210 into 20. 210 into 2, 420. 420, we have a 0 missing. So 4,200. What we have is 4,197. That means just 3 less than that. 3 less than 4,200. That 3, where that 3 come from? Possibly the number of letters here. So ultimately what you get here, it's 4,200. And if you subtract a 3 from that, you get what? 4197. If you apply the same logic here, 1 into 18 into 5. 18 into 5 is 90. 90 into 1 is 90. So we get what? 90 minus number of letters here? 3. So 90 minus 3, we got 87. Perfectly all right. The pattern is correct. So that means you can apply the same pattern for the word cat. So cat, what are the letters? C-A-T. So 3, 1, 20. So when you multiply 3, 1, 20, what you get is 60. 3 into 20, 60. And 60, and how many letters here? 3 letters. So 60 minus 3, the answer right here, 57. So straightforward question. Next one, 24. Which of the following numbers will replace the question mark in the number series? 458, 462, 446, all the numbers are 400 something. Except this 518. So it is what? 58, 62, 46, 82, etc. So what kind of a pattern we have? Look at it. 458 plus 4 is what? 462. And minus something is 446. Then we have 482. Then we have something missing, 518. The first difference is 4. Second difference, 462 And this is what? 446. 446 plus 4 is 450. 450 plus 12. 450 plus 12. So ultimately, how much is that? 12 plus 4, 16. So this difference is 16. How much is the difference? Minus 16. Then 446 and 482. 446 plus 40 is 486. This is not 486. This is 482. So 4 less than that. 4 less than 40. So it's 36. So the next difference is going to be 36. Then 482 and what? We have no idea. Well, now let's look at the pattern here. It's 4. This is minus 16. This is 36. So what are those numbers? Well, 4 could be what? 2 square. And this is minus 4 square. This is plus 2 square. This is minus 4 square. Then again what? Plus 6 square. So if you take it that way, 2 square, 4 square, 6 square, next one must be 8 square. So how much? Minus 8 square. 8 square is 64. So 482 minus 64. 482 minus 60, 422. 422 minus 4, 418. So if it is 418 is the number here, 418 is the number here, then what is next? 2 square minus 4 square plus 6 square minus 8 square. Next one is plus 10 square. So 418 plus 10 square, 518. That's it. So we got the pattern and we got the answer. 418 is the answer right here. And this is logical Venn diagram type question. Earlier we have done a Venn diagram type questions and deductions or syllogism. But this is totally different. This concept is totally different. We'll take a look at this. Select the Venn diagram that best represents the relation between the following classes: bed, bedroom, house. So bed, bedroom, house. Just apply your common sense. Bed, bedroom, house. What is the connection? Or, well, we can see that there is a house, and inside the house there is a bedroom, and inside the bedroom there is a bed. So this is bedroom. So inside house we have what? Bedroom. Inside bedroom we have bed. So ultimately this is what it is. Bedroom. This is the house, this is the bedroom, and this is the bed. No other answer choice is appropriate for bed, bedroom, and house. Sometimes you may have questions something like similar to the carrot, vegetable, potato. So carrot, vegetable, potato. So what is the connection here, or what type of a diagram it is? Which diagram represents this three items here? Carrot, vegetable, and potato. Well, carrot is a vegetable, potato is a vegetable, right? But carrot and potato are two different things. So the answer is going to be a vegetable circle. It's a vegetable circle, and carrot must be inside, and potato must be inside as well. However, there is no intersection between carrot and potato. So look at the diagram here. This one represents what? Vegetables. And this is carrot. This is potato. And many other things, like sometimes you may have animals. Animals, we have bear, we have tiger. So animal circle, inside the animal circle, we have bear, tiger. And sometimes we have, shirts in a shop. Shirts in a tailoring shop. Something like we have shirts. Then we have blue. Then we have white. So shirts, Some of the shirts are blue. Not all the blue are shirts. So, well, some of the shirts are blue and some of the shirts are what? White. So, shirts right here, blue here and white here. This is what it is. So, this is pretty much, logical Venn diagram type of questions. There are wide varieties of items in this. So, let's say animals, dog, dove. So animals, dog, dove. What would be the diagram appropriate for animals, dog and dove? Well, we know that dog is an animal, so dog must be inside the animal diagram. At the same time, dove is a bird, right? It's not an animal, it's not dog. So dove would be different. So ultimately, this would be the diagram for that. When the diagram is given for the exam, there won't be any marking. It would be like this. So the diagram which represents animals, dog and dove would be like this. Alright, so we have done 25 questions which are the part of the test you had done earlier. So we have completed that questions and definitely we'll have more sets of questions for discussion. Thank you for watching. See you next time. Bye-bye.